All right, let's practice using the product rule and quotient rule to calculate some derivatives. Start here with number 3. And well, to use the product rule, we want to view this function as a product of two functions. So I'm going to rewrite it as f of x equals 5x plus 2 times 5x plus 2. And so then if I want to take the derivative, f prime of x, that's going to be the derivative of the right side here. Okay. And so to do the derivative of this product, I'm going to write that product twice with a plus sign in the middle. And then in the first product here, I'm going to take the derivative of just the first one, first factor, and then the second product, I'm going to take the derivative of just the second factor. And okay, so the derivative of 5x plus 2 is 5 plus 0, or just 5. And that's times 5x plus 2. And then from this product here, we have the 5x plus 2 times the derivative of 5x plus 2, which is 5 again. So we're done taking derivatives, and we just have to simplify. So from the first product here, we have distributing this 5 gives us 25x plus 10. And distributing the 5 here, we get the same thing, 25x plus 10. So altogether we have 50x plus 20 as our answer. Now another way to do this problem would be to multiply out our function f of x. And so if you sort of FOIL this binomial here, you get 25x squared plus, let's see, 2 times 5x times 2 would be 20x, and then plus 2 squared, which is 4. And so that's just a polynomial, and we can take the derivative using the power rule. 2 times 25 is 50x plus 20, and the derivative of the 4 is 0. So we do get the same answer using both methods. All right, here's another one to practice the product rule. So g prime of x is going to be the derivative of what we have on the right side. And according to the product rule, well, remember, we just write this product twice, with the plus sign in the middle. And derivative of the sort of outside factors here. Derivative here is 2. 2 times negative 3x plus 1. And then 2x plus 5. Derivative here is negative 3. And if I distribute the 2, I get negative 6x plus 2. And then over here, if I distribute the negative 3, I get, let me change that to a minus sign, negative 6x minus 15. And so combining the negative 6 and the negative 6, we have negative 12x, and 2 minus 15 is negative 13. Okay, so negative 12x minus 13. Now, once again, we could have done this one by, first of all, expanding our function g. So that would be 2x times negative 3x is negative 6x squared, plus 2x times 1, plus 5 times negative 3x is negative 15x, plus 5 times 1 is plus 5. And that g of x simplifies to negative 6x squared minus 13x plus 5. And using the power rule, we get the derivative of that to be, well, 2 times negative 6 is negative 12x to the 1, minus 13, and the derivative of 5 is 0. So once again, Same thing as we got using the product rule. All right. How about the quotient rule? Well, remember what this rule is. Take the derivative of this fraction. We do low d high minus high d low over low squared. So the low d high is going to be the denominator times the derivative of the numerator. And then minus high d low, so the numerator times the derivative of the denominator. All over low squared. So the square of the denominator. I noticed that in this step, I haven't actually taken any derivatives. I've just sort of put a prime where I need to take a derivative, okay, to remind myself of what I still have to do. Once you get used to doing this, you may sort of skip this step and just go ahead and take the derivatives as you go. Okay? But it's good to write that step in when you're starting. All right, so now we take those derivatives. The derivative here is 6x minus 0, so just 6x minus 3x squared minus 1, and the derivative here is just 2. Okay. And I'm just going to give my answer in factored form, so I'm not going to expand that denominator, at least not yet, if at all. All right, so now we're done taking derivatives. We just have to simplify the numerator. 2x times 6x is 12x squared, and then plus 6x. And okay, then we got negative 2 times 3x is negative 6x squared, and negative 2 is plus 2. All over our denominator here. Okay, and then combining, we have 12x squared minus 6x squared is 6x squared plus 6x plus 2. And I don't know how much we can simplify that. I suppose we could factor out a 2 from the numerator. And we're left with 3x squared plus 3x plus 1 over 2x plus 1 squared. And I don't know off the top of my head if this quadratic polynomial will factor or not. I'll let you think about that one. But this would be fine as an answer. Okay, let's try another one. This one is a little more tricky. It's got a square root and a cube root in here. So before we take the derivative, let's rewrite this in more familiar form. So let's see, t minus, okay, square root of t is t to the 1/2, okay, over t to the 1/3. All right, good. So if I'm doing the derivative of this, then I do low d high, so t to the 1/3 times the derivative of t minus t to the 1/2, whatever that is, minus high d low. So minus t to the 1/2 times the derivative of t to the 1/3. All over low squared, right? T to the 1/3 squared. Okay, time to take derivatives. T to the 1/3, and then the derivative of t is 1, minus, and then the derivative of t to the 1/2, you bring down the 1/2, and you reduce the exponent by 1, so it becomes negative 1/2. Okay, lost my 1, there we go. And copy this part. Okay, the derivative of t to the 1/3 is going to be 1/3 t, and then I have to do an exponent 1/3 minus 1, which is negative 2/3. And all of this is over. All right, well, when you do t to some power and then to another power, you end up multiplying those exponents. All right, so this is t to the 2/3. So the derivatives are done. We just need to do some algebra to try and make this look a little nicer. Okay, so to distribute the t to the 1/3 into this factor, we get, well, we multiply it by 1, and then we have minus 1/2 t to the 1/3 times t to the negative 1/2. And in that situation, we add the exponents. So we have to figure out what 1/3 minus 1/2 is. And if we put it over a common denominator of 6, we get, let's see, 2/3 minus, 2/6 minus 3/6, which is negative 1/6. All right. And then on the right side here, we have negative 1/3 t times t to the negative 2/3. That's an exponent of 1, right? So 1 minus 2/3 is 1/3, t to the 1/3. And then in the second term here, I have minus a minus, so those signs go away. So I have plus this 1/3 times t to the 1/2 times t to the negative 2/3. And, well, 1/2 minus 2/3 is, again, going to be negative 1/6, okay? So t to the negative 1/6. And all that over t to the 2/3. Okay, good. So this is looking nice. We have a couple t to the 1/3 terms. We have 1 times it minus 1/3 times it, so that's 2/3 t to the 1/3. And then we also have a couple t to the, I forgot a t over here, didn't I? There we go. A couple t to the negative 1/6 terms. And we have, well, 1/3 times it minus a half times it, which would be negative 1/6. So minus 1/6 t to the negative 1/6 all over t to the 2/3. And finally, well, if I take this term and divide it by t to the 2/3, what that does is it takes the, because it can give you an exponent of 1/3 minus 2/3, okay? So this is 2/3 times, what is 1/3 minus, it's negative 1/3, t to the negative 1/3, and then, okay, minus 1/6, and t to the negative 1/6 minus 2/3, well, what is that? Negative 1/6 minus 4/6 would be 5/6. So t to the negative 5/6. And that looks pretty good as an answer. So, all right, there's a few more examples of the product and quotient rule. I hope those will be helpful.